Okay, I'll try and finish up part B of the curves analysis tools, and we'll take it off by, I think we made it as follow as torsion, and we'll try and continue with the same type of curves. So let's jump in here and see if I can find my curves. There they are. Basically have them set up. I'm going to be using them through this whole script, so we'll bring them down. I have a parameter on those curves, so what happens is I end up locating a point within that curve. Obviously, that's the one, and it indicates the data that's associated with torsion. So just a fact, just a informational data generator. I'm going to reparameterize nearly every curve in here. I didn't reparameterize this one, I'm not sure, but curve domain is pretty easy. If you set your domain, just pop in a number slider. It's going to read that domain from 1 to or 0 to 38. You locate the point on that curve right here of where you are. Sorry, you're going to come out with the same curve as you went in. It's going to retain the same shape, but you're going to change the domain to a 0 to 1, especially if you reparameterize it. But don't take that reparameterizing on. You see that the domain changes from a domain from uh, 0 to 100 set at 54. It's pretty interesting that it has no effect over all the domain that's on there, and I guess that's just dealing with length. So I reparameterize everything to get a 0 to 1. I'm going to continue with evaluate length, which I do use quite a bit. You're going to take in that curve, obviously. You're going to evaluate the length along, as long as it's reparameterized, a point in there. You're going to get the point. And you're also going to point tangent, which I like to draw a line in between so you can see that as you start to play with it. And I did that earlier in another one. It also gives you the parameter along the curve of where you're at. You'll notice the parameters ranging from that whole range that you had coming out of this one before we reparameterized. Once again, if I send it into reparameterizing, we're going to have that point move between 0 and 1. So that's not too hard to figure out. See what these, I mean, a lot of these double up and do things that you might not need, but it's nice to know that there's little nuances about all of these nodes. Curve length's pretty easy. Obviously, the length is set there, but if I reparameterize that, it doesn't matter. I'm still going to have the length set to the Rhino window of whatever it is length in Rhino. Nice way to get it. Now, if you're in Rhino, you just take distance, and I think you get the same distance on that curve. Uh, Curve length. It's going to give me exactly a domain of where I want to be. So if I have a domain of 12, let alone if I have a domain of, if you set this domain differently, you're going to end up getting a different length according to that. So like I said, number slider will go in, you'll have your domain 0 to 41, and then you're given the length of what that will be. It's kind of like playing with scale to find different lengths. Length parameter, let's jump in again. I'll keep sliding this down. Ooh, so it doesn't get too confusing. You're going to go in and have the curve parameter. If I reparameterize it, then basically I have the ability to change the length of one curve to the other, but it adds up to the total. So I'm splitting that at some point along that parameter. And I have to wonder what happens if I end up, I don't think I get additional lengths. I'm just curious if I put in 2 parameters. I didn't try that. And that's why you want to play with these nodes. Hit shift and pull in another parameter and see what happens. Oh, you just get grafted data that gives you 2, and then I guess I could graph that, and I'd have 2 categories. Okay, I have data that are separate, and I can use them for different things. So that's kind of interesting, getting 2 bits of data out of there as I do it. But you're going to want to understand a little bit about, obviously, your param viewer and your panels and information that comes out. Let's take that graph. I like this short segment, so it'll tell you exactly what the shortest and longest segment is, and then also gives you the domain that's associated with that. So if we start, I mean, it's pretty much the same information coming out of both the shortest and longest on this one. I'm sure what happens if I reparameterize. Yep, you just set it off to the domain. We'll go between 0 and 1 again. Let's finish off here with a little bit of circle tool. This is fun little ending. I think it's kind of a cool script. I basically built a circle. I'm going to show you this. I built a point that's inside that circle. I built a point outside of that circle, and I built a point on that circle. Then I built a second circle, which I moved over here, and I have control over how far I want to move that circle, over here, over there. So that's kind of fun. So if you watch this, right now, both circles are here. If I move the second one, this first circle falls outside of it, and of course the data changes. And what I want you to analyze is the relationships of what's happening in 0 being outside, 1 being coincident, 2 being inside. This data changes as I move this, so 0, but I think I can bring that other one, relationship-wise, relate that 0, 0 to the numbers that are there, and as I slide this and pull that first point, if you follow it back inside that circle, and the other one being coincident, at one point, you can see that data changes from -1 to 0. It'd be very hard to hit that point exactly on that curve, but you can see it actually happens right through there. There's a little bit of data changing. So what I'm looking at is this panel down here. Pretty interesting. I've been wanting to do this because I want to build geometries and have walls and units and houses and structures, and I'm going to be using this an awful lot. Points in curve, to how I assess data. Now, otherwise, I'd have to get into programming and thinking like the Python, and then I'd have if contained. You could start playing with XYZ attributes of something like does that line up? And that's a lot to wrap my head around. I do have a very interesting script that I pulled from Arturo Tedeschi's book, which I think is just awesome. And what happens is you start to translate. I'm throwing this in as a bonus at the end, is you're starting to think things like conditionals. And I'm trying to apply this to geometry. And he does this through one of his chapters, which is just outstanding. I think chapter 2. And he goes in, like, you start following this. Like, if that grows greater, then obviously you're changing your Boolean factors on that. Really nice conditionals. Creating a series with different use of radii. So you start, I'd have to bring a curve in to do that, and a curve in here. I think there's circles. Here's one that actually deals with text, which is pretty cool. The cat is on the table, concatenate that into one text. This is nice that if x is greater than, you're concatenating exactly what it wants to be, and you're pulling this file out as information. This is nice. If conditional statements are really where I'd have to go geometrically. And for me, the reason I'm bringing this up is that kind of points in circle or in curve or out of curve is the same way of saying if this, then do that. And that's where I'm going to try and take it. And I know I can make this more and more complicated as I get into Python and scripting in that, and I will try to do that. The sense of containing is very nice, and this is nice that I can actually read panels and decide, hey, the word line's in there, so I can say that's true. And if I took this out and made this line that's here, if I extract it, and I will just do that as an example, and then I will downsize my Grasshopper script, you'll see, if I downsize that script, pull it back over, where'd my Rhino go? Should be in there somewhere. There it is. Let's pull my Rhino back over here and basically grab that geometry and turn it to preview. There it is. If I take that curve and, leave this. If I take that curve and build a curve like this, and I import that into a line tool, if I say, we're going to set that 1 to here, we'll do it again. There's the line. But if I set this line to a curve, obviously it's not going to go in a line tool if it's not a curve. If I set that to here, curve tool, and I plug that in, now watch, there's not going to be a line in there. Or, I don't think there, but you see reference planar curve, it's going to say false because it now understands there's no line in there. Only here does this say line and then the line where it's at. So you can actually use text over top of digits to find if things are true and false. That's getting pretty awesome. So that's a little bonus at the end of that for those that stuck around and watched the end of the video. I'll keep moving. We're going to go back into curves, and we're going to finish up with utilities, something we hadn't done yet. I use explode all the time, and we'll go all the way through to smooth polyline. Very cool things, and I know a lot of people use pull curves and project and things like that all the time with what they're doing. Reduce I haven't even played with, so I have to figure that out. Actually, I want to look. Reduce the polyline by removing least significant vertices. So that's kind of cool. All right,